In this guide, standard OpenID Connect has 4 limitations that SIOP directly addresses. SIOP works in 4 steps. Let's look at the real wire format, and 4 shifts are defining where SIOP is heading right now. Identity Expert, powering you to be an expert in identity. Here's the privacy cost of centralized identity that almost nobody talks about. Every time you click sign in with Google, your identity provider learns which site you just authenticated to from which IP address at what time. Over months and years, Google or Okta or Microsoft builds a comprehensive map of every service you use. That's not a bug, it's an architectural feature of federated identity. The IDP is always in the loop, and being in the loop is how it can revoke access. But what if you could authenticate to a website or a service without any third-party IDP being involved at all? What if the authentication assertion came from your own wallet, signed with your own private key, and the verifier validated it locally, no callbacks, no phone home, no IDP tracking? Today we're covering SIOP 2, Self-Issued OpenID Provider. The acronym is SIOP and it's pronounced SIOP. SIOP 2 is an extension to OpenID Connect where the user's own device, typically a digital identity wallet, acts as the OpenID provider. The user signs a self-issued ID token with their own private key. The verifier validates the signature using the public key embedded in the token itself, a field called sub_JWK. No third-party IDP is contacted. SIOP is one of 3 protocols in the OpenID 4VC family. OID 4VCI issues credentials into wallets, OID 4VP presents credentials from wallets, and SIOP handles wallet-based authentication. Together they form a complete decentralized identity stack on top of OAuth 2. This is why EIDAS 2 mandated SIOP for the EU Digital Identity Wallet. Think about how a passport works at an international border. The border guard checks the passport, they verify the photo, the signature, the government seal, the machine-readable zone, they confirm it's genuine, and then they let you through. At no point does the border guard call the issuing government's headquarters and say, please confirm that this passport belongs to this person. The verification is done locally using the cryptographic properties of the document itself. SIOP works exactly like a passport. Your wallet creates a self-signed assertion, the ID token that says, I am the holder of this key pair, here is my public key, here is a nonce binding this to this specific session. The verifier checks the signature using the public key embedded in the token. Verified, done. The issuing government, the IDP, is never called. But here's where SIOP goes further than a passport. Your passport has your name and photo printed on it, it's an all-or-nothing disclosure. SIOP integrates with verifiable presentations, which means alongside the self-issued ID token, your wallet can present a subset of verifiable claims from credentials issued by trusted parties. An employer can verify that you have a degree without learning your name. A pharmacy can verify that you're over 18 without seeing your date of birth. SIOP is the authentication layer. Verifiable credentials are the claims layer. Together, they let identity work the way physical documents should have always worked, portable, selective, and decentralized. Standard OpenID Connect has 4 limitations that SIOP directly addresses. First, mandatory centralized IDP dependency. Every OIDC flow requires a trusted third-party IDP for cross-border, cross-organization, or Web3 scenarios where no single IDP is trusted by all parties. OIDC fails as an architecture. There is no standard OIDC flow where the user self-asserts their identity. Everything is mediated by a provider. Second, IDP surveillance and tracking. Because the IDP validates every token, it sees every authentication event. In privacy-sensitive applications, healthcare, legal services, financial advice, the IDP becomes an involuntary data aggregator with a detailed picture of every user's service usage. Third, identity silos by provider. Your Google identity is not portable to systems that don't trust Google. Your enterprise Okta identity is not portable to your personal life. OIDC creates identity that is bound to the provider, not to the user. When the provider changes policy, raises prices, or gets breached, the identity goes with it. Fourth, attribute disclosure is all or nothing. Standard OIDC scopes, OpenID, profile, email, release structured attribute sets. There is no built-in way to prove age without disclosing date of birth, or prove employment without disclosing your full employment record. SIOP's integration with verifiable presentations and presentation exchange solves this. The wallet presents exactly the fields the verifier requested and nothing more, enforcing selective disclosure at the protocol level. SIOP works in 4 steps. Step 1. The verifier called the relying party sends an authorization request to the wallet. The request carries response type VP token spaced token, a client ID pointing back to the verifier, a nonce for replay protection, and a presentation definition, a JSON object describing which credential types and attributes the verifier requires. This request is typically delivered via QR code for cross-device flows or a deep link like OpenIDC:// for same-device flows. Step 2. The wallet prompts the user to review what's being asked for. The user sees the verifier's identity and the specific credential attributes being requested: degree, name, employment status, age, and must explicitly consent. This consent UI is the security boundary that prevents over-asking attacks. Step 3. The wallet creates two tokens. First, the self-issued ID token, a JWT with issuer set to the literal string https://selfissued.me/v2, the subject set to either a DID or a key thumbprint derived from the user's key, and a sub_JWK field carrying the user's public key. This token is signed by the user's private key. Second, the VP token, a verifiable presentation containing the credentials matching the presentation definition, signed by the wallet and including the nonce for binding. Step 4. The wallet posts both tokens to the verifier's redirect URI via direct post response mode. The verifier validates the ID token signature using the public key from sub_JWK, validates the VP against the credential issuer's public keys, confirms the nonce matches, and confirms the presentation definition is satisfied. Access granted, no IDP consulted. Let's look at the real wire format. The SIOP authorization request is typically delivered as a URL with the scheme OpenIDC://. The query parameters include response type set to VP token id token, cliented pointing to the verifier's callback endpoint, redirect query set to the same endpoint, scope OpenID, the nonce for replay prevention, state for CSRF protection, response mode set to direct post, cliented scheme set to redirect query, and a presentation definition JSON object that has been URL encoded. The presentation definition object has an ID and an input descriptors array. Each descriptor specifies the credential type required via JSON path filter, in this case checking that the VC type array contains university degree credential, and the fields the verifier wants to see, like the degree name. This is selective disclosure at the protocol level. The wallet only discloses what's in the filter path. The wallet responds with a direct post to the verifier callback. The body carries the ID token, a compact JWT, the VP token, a compact JWT containing the verifiable presentation, and a presentation submission object that maps each input descriptor to the specific credential in the VP token. The self-issued ID token decoded shows is set to the self-issued me v2 URI, subset to a DID key DID derived from the user's key, odd set to the verifier, exp and IAT for freshness, and the sub_JWK field carrying the raw EC public key. The verifier uses sub_JWK to verify the ID token signature locally, no IDP involved. SIOP shifts trust from a centralized IDP to the wallet and the verifier ecosystem, which changes the threat surface in important ways. The dominant threat is verifier overasking combined with weak consent UX. In standard OIDC, the IDP vets relying parties and enforces scope limits. In SIOP, the user's wallet is the only gate. A malicious verifier can request every credential the wallet holds, government ID, medical history, financial records, in a single presentation definition. If the wallet's consent UI doesn't make the overasking obvious and easy to reject, the user discloses everything. Mitigations: wallet-enforced trust registries that verify the verifier's identity, clear consent UI showing each requested field individually, and cliented scheme equals verifier attestation, which requires the verifier to present a third-party attestation before the wallet will process the request. VP token replay is the second major threat. An attacker captures a signed presentation and resubmits it to the same or a different verifier later, impersonating the user. The defense is binding the nonce from the authorization request into both the ID token and the VP. A verifier that checks nonce freshness and rejects presentations with stale issue times defeats replay entirely. Cross-device session fixation is the QR code attack. An attacker displays the verifier's legitimate QR code on their own screen, tricks the victim into scanning it, and the victim's wallet authenticates into the attacker's session. Defense: bind the authorization request to the initiating session via signed state, use same device flows where possible, and display channel binding confirmation to the user. Finally, sub_JWK reuse creates cross-verifier tracking. If the wallet uses the same key pair at every verifier, the key thumbprint becomes a persistent pseudonymous identifier that any two verifiers can share to correlate activity. Defense: generate pairwise keys per verifier. 4 shifts are defining where SIOP is heading right now. First, SIOP 2 and OpenID 4 VP are finalizing. The OpenID Connect self-issued v2 implementers Draft 4 from 2024 and OpenID 4 VP Draft 23 from 2025 are converging toward final specification status. Notably, OpenID 4 VP is aligning around DCQL, the digital credentials query language, as a successor to Presentation Exchange's presentation definition syntax. DCQL offers a simpler, more regular query structure and is likely to become the default in new implementations, while presentation definition remains for backward compatibility. Second, the EU Digital Identity Wallet is the adoption engine. The EIDAS2 architecture and reference framework version 1.4 mandates SIOP 2 plus OpenID 4 VP for wallet-to-verifier flows in all 4 large-scale pilot programs. All EU member states must offer compliant wallets by late 2026. This regulatory mandate has pushed browser vendors Chrome and Safari to begin exposing the W3C Digital Credentials API, navigator.credentials.get with a digital parameter, enabling same-device wallet presentation without custom URL schemes or app switching. Third, SDJW-TVC is becoming the dominant credential format for SIOP deployments, alongside ISO MDOC for government IDs. W3C JSONLD verifiable credentials are being displaced in this context because SDJW-TVC's selective disclosure via salted hash disclosures is simpler to implement and verify, and the format is compact enough for mobile flows. Fourth, high-assurance profiles and trust frameworks are closing the verifier impersonation gaps. The OpenID Foundation's HAIP Working Group and the IETF OAuth Group are converging on required cliented scheme equals verifier attestation, mandatory holder binding via the CNF claim inside credentials, and specific signing algorithm requirements, systematically eliminating the attack surface that the verifier over-asking threat exploits. Next on Identity Expert, OID 4 VP, OpenID for verifiable presentations. Subscribe so you don't miss it. All primary sources cited in today's guide are listed on screen. You'll find direct links to the RFCs and specifications in the video description below. If this breakdown helped you understand the topic better, please subscribe to Identity Expert. We publish a new protocol deep dive every week. Thanks for watching. If there's a specific identity standard, authentication flow, or security protocol you'd like us to cover next, drop it in the comments below. We build our content based on what the community asks for. Subscribe and hit the bell so you never miss an episode.